Okay, that's great. I think we're ready to go. So again, thanks for joining us for this Diesel Progress webinar, Agriculture, Emerging Technologies and Trends. This webinar has been brought to you by our gold sponsor, ZF, and our silver sponsor, Cummins, and it's in collaboration with AGRITECHNICA. My name is Julian Buckley, and I'm the editor of Diesel Progress International magazine. Now, DPI and Diesel Progress, our parent magazine, have been covering the agricultural machine sector pretty much since they first started publishing. But what we're seeing now is some new technologies and trends that are really mixing up the agricultural machine market. So to cover those, we have 6 speakers today from 6 different companies, and they are FPT Industrial, Raven Industries, DLG, Hummingbird EV, Burro, and Danfoss Power Solutions. So each presenter will offer their insights into what they believe are the trends that we're likely to see across the agricultural machine market. Now, the presentations will each last about 10 minutes. Now, after each one, we will have a short question and answer period. If you, the attendees, can forward your questions for those presentations using the Q&A button, that would be great. If you use the chat button, we won't be able to see your questions. So please remember to use the Q&A button, and please submit questions for the presentation that you're watching at that time. Okay, so without any further ado, let's move on and get with our first speaker. So coming up, we have Pier Paolo Bifali. He's Product Engineering Vice President for FPT Industrial. Now, Pier Paolo has been working in the field of engine development and industrialization for 20 years. In his current role, he is leading a fundamental transformation in the industry, evolving the engineering community from a combustion and mechanical DNA to a propulsion system-oriented approach. So, Pier Paolo, please turn on your camera and let's see your presentation. Thank you very much.
Thank you very much. Okay, my name is Pier Paolo Bifali. Nice to meet you, everybody. I'm in charge of powertrain product engineering at FPT Industrial. I'm going to talk today about hybrid solution for agricultural application for tractors. This is our identity card. As part of CNH Industrial Group, FPT Industrial develop and manufacture engine, transmission, and axles for industrial application. We cover a range of power in between 40, 50 kilowatt and 1 megawatt, with application to trucks, commercial vehicles, buses, but also construction equipment, agricultural machine from small tractors to big combined and harvesting machines, as well as power generation, marine and train application. We are also entering the field of electrified powertrain solution. We are about to launch our first 2 products for electrified driveline, heavy-duty application of a twin-motor e-axle for heavy commercial vehicle, and a compact, powerful front and rear-wheel drive electric drive unit for sport car next year, together with battery development and manufacturing in Turin, in our plant in Turin, for commercial vehicle and buses. We are working, operating over 8 technical centers worldwide, and those are the main figures on the chart. So why electrification? For the on-road segment, electrification is a a must in order to achieve zero emission, lowering CO2 to comply with the tightening legislation framework coming and upcoming with Euro 6, Euro 7, and worldwide certification regulation. For the agricultural segment, we see more room to use electrification as enabler for electrically assist the machine, the engine, to improve the overall machine productivity and fuel economy. Our concept of hybrid tractors consists of a downsized combustion engine, multi-fuel, so that the engine can run either on diesel or natural gas, with an integrated electrified machine coupled with the engine, with the compact engine, to replace the original conventional unit on the machine. This also can bring a simplification of the after treatment, and coupled with electrification of auxiliaries and implements, provide or can offer great benefit in terms of fuel economy. To give you some numbers and some features, with the very first demonstration units, we achieved a double-digit fuel consumption improvement, close to 20% on the specific mission, by combining the downsizing of the engine together with the very high efficient and controllable electrified auxiliary on board of the tractor. This is, of course, translated as a full CO2 reduction for the machine, together with power increase and better transient response and general drivability and stability over the mission, thanks to the electrical assist that the electrical machine can offer on the tractor. Last but not least, with electrified PTO, the maneuverability is improved, but also the system can be oil-free, so offering one more point of sustainability of the application for the farmer. The heart of the tractor, of the hybrid solution, is our F28 hybrid. Is our 4-cylinder inline newborn engine, 2.8 displacement, liter displacement, coupled with a integrated motor generator on the flywheel side that we conceived in the way to make it scalable. That means both operating at 48 volts for a mild hybrid architecture, but with the same compact layout, scalable to a high voltage solution, offering some zero emission operation opportunity and very, very low noise output when the electrical mode is activated. F28 engine can run either on diesel or methane or biomethane, of course, for the agricultural application. And we can also leverage on a simplified after treatment architecture, saving the SCR. That means no urea and reduced complexity of the after treatment and improved reliability of the system on the field. What maturity we achieved, where we are today. In this moment in time, we have run already the testing on the powertrain test bench with the hybrid unit, reproducing several duty cycle and mission operation of the tractor. So confirming the performance increase and the fuel economy, this big step in terms of fuel economy, when this hybrid machine is coupled with 48 voltage electrified implements like a leaf stripper, disc harrow, or sprayer pumps, which can provide very high efficient operation for the tractor compared to the current mechanical and hydraulical implements available. We have planned next year in 2022 to run the field trial on a small fleet of tractors for this 48 voltage arrangement, and we will go ahead with the high voltage solution first on the test bench and on the dyno, and then the following year on the field. In this moment in time, I have to say that the main challenges behind the application or concrete application of such technology in the field of tractors are two. One, as you can well imagine, still the high cost of hybridization, of electrification of the tractor, which is definitely slowing down the introduction of electrified solution in the agricultural field. But this is something that can be partially or even totally compensated and recovered by the improved features starting from fuel economy and fuel expense that such an arrangement can offer. And the other point is the development of the electrified implements, which is currently ongoing at supplier and partners with cooperation with FPT and with CNH. At this moment in time, the maturity and the readiness and also the cost of 48 voltage implements in place of mechanical and hydraulic are still not yet in the position to I would say offer a competitive price, a competitive cost to apply on the tractor. We see opportunity to overcome this challenge in the next 2-3 years to have ready a competitive product, electrified hybrid tractors with our F28 in 2025 on the field. And I'm done, Julian. Thank you very much.
That was great, Pier Paolo. Thank you very much for the presentation. Excellent, good stuff. I've just got a couple of questions for you, if that's okay.
Sure, go ahead.
One of our attendees has put forward, do you expect the hybrid solution to also be carried over to mid and large displacement engines? Yes,
this is definitely something we are looking at. I think that in that case, for large tractors, the high voltage solution with more powerful implements application is needed. So low voltage cannot offer real advantage for, 200, 300, 400 horsepower tractors and machines. In that case, the readiness of the products on the market is not at the same stage of the 48 voltage. So I see room, but in a kind of second step. Right. That begs the question too. Excuse me. What was the driving force behind the F28? Is it regulatory, where you had to fall within emissions, or was it? No. The reason why we developed the F28 was mainly to replace, I would say, our product line with the ultra compact and powerful engine capable to operate with diesel and biomethane and methane. And in this case, the great advantage for the customer, the advantage for the customer can be two. When you can replace a 3-cylinder inline, so a compact 3-cylinder inline with a 4-cylinder at the same room, in the same engine compartment, and this is definitely bringing all the benefit in terms of performance, in terms of MDH, on the machine. And on the other end, you can downsize those applications that engage a portion of the power available, in the range of 30–40% of the 100 horsepower available, with a say lower displacement engine, so improving in general the fuel economy and the overall cost of ownership.
Well, and where, just as a last question, where do you see this going? Do you see the hybrid engine the start of a route towards full electrification for FPT, or is this?
Yeah, Julian. We think that there will be no unique solution. Like on the on-road industry that we live and is pulling no electrification on the market, also for the off-road agricultural and construction equipment, we do not see a unique solution for all the application. So we think that hybrid is the correct solution for these specific small tractors with quite dynamic operation on the field. We see some opportunity instead for hydrogen in the form of fuel cell or hydrogen combustion engine in the future for zero CO2, for very say energy demanding application, like harvesting and combine that cannot cope with battery limits in terms of weight, in terms of autonomy that the battery can assure. So I think hybrid is part of a set of solution that the agricultural segment can get from the electrified field.
That's great. Pier Paolo, thank you very much for your presentation. Thank you for joining us today. That was great.
Thank you very much, Julian.
Thank you. Cheers. Okay, our next speaker is Sarah Waldner, and she's Senior Director of Global Sales at Raven Industries. Now, Sarah has been with Raven since she joined as an intern. She has gone on to be a senior member of 3 different divisions, most recently looking at how to bring autonomy to the machine market. And thanks for joining us, Sarah. I see you're ready to go with your presentation, and I will let you get on. Thank you.
Great, thank you so much, and hello everyone. So as he mentioned, my name is Sarah Waldner and I lead the global sales team for Raven Industries. And Raven has been a company that has been bringing technology and really various levels of automation to the agricultural industry for several decades now. And we are now leading the path to automation in ag, both in automation and in autonomy. And we believe that the technology we have and that we've invested in over the years is paving the path for us to do that. At a very basic level, the things that you're trying to accomplish in ag don't change a ton over time. We have to take care of our land. We have to get the very best crop we can. We have to manage our inputs. We have to manage what's available to us with machine and labor and people and all of the other things that go along with it. What has changed is the way in which we do that, with increased field and farm sizes, with increased size of machinery, with the need for increased technology and the increased regulations that drives a lot of change in how we're trying to get all of that done. And we really try hard at Raven to stay close to our customers and understand the challenges that they are trying to solve and the challenges that they're facing and how they stay the same over time and how they have changed over time. And what really excites me about this and talking about both automation and autonomy is the problems that it is helping our end customers, the growers and farmers and agribusinesses solve in these areas. Really, to me, there's 2 things when we think about solving great challenges that I want to delve into a little bit, and they really come to automation and autonomy. And when we think about all of the things that are changing in our world today, we hear consistently from customers a few things. We need to get more done with less. We need to get more coordination of work, more consistency of work. And in general, and it's different in various regions, but in general, labor is getting tighter. And labor is a problem in 2 areas. First, sometimes getting that labor at all. And secondly, getting the labor that is the skill set you need at the time that you need it. And those are really big challenges. At the same time, when you look at the push for transparency in our food products, when you look at the changes that you see happening in regulation, whether it's the reporting that's needed, whether it's the reduced use of chemical inputs, whatever that case is, everything and many things about farming is getting more complicated and more technical. And that's where technology comes in. And for us, automation is about automating tasks. And we really have been doing this for decades. When you think about guidance and steering, when you think about other technologies that have come into ag that used to not be in place, really, if you think about it, they fall into a couple buckets. Either one, they have allowed a low-level task to be done automatically that you just want to not worry about, or it helps produce a quality, consistent output on a very high-level task. And of course, there's a range in between. And that automation really is about taking care of those tasks, whether they are low-level tasks or high-level tasks, and producing a consistent output, maybe irregardless of the quality of the labor or the quality of the skilled person in the cab, or despite there maybe being a person or not having a person in the cab. And autonomy then comes very close beside it, and that really is levels of either somebody in the cab, but hardly any interaction, to maybe someone in one cab, but in a second cab, tractor or whatever type of machine in the field doesn't have a person in it, to maybe somebody at the side of the field, and maybe someday someone only in the office, and managing it from there. And so I think what's really important to remember about autonomy and automation is autonomy can be a really fun and exciting word. And I think what's really important and what we're really focused on is what is the value to the end customer at the end of the day. At the end of the day, the people that are making their money and they're living off of the land have to either be able to get more done or get what they need to get done more profitably or more effectively. And so at the end of the day, we're really looking at how can we provide value there. I've seen many SPAT technologies over my tenure where the technology itself is really awesome and exciting, but it's not able to be put into the way in which people work. It's not able to be put into their workflow. It doesn't solve enough problems to actually make a difference to their overall success. And so that's one thing that we've been really focused on here at Raven. Next, I want to talk to the two specific technologies we've brought forth and are in the market right now, and talk to them a little bit, and then where we're going. So first of all, talking about OmniDrive, that is the first driverless ag technology, and it is specifically now for grain harvest operations. So really what it does is it enables the grain cart tractor to not have a driver in it, and the combine harvester to really be in control. And so while that combine harvester is combining, they can cue the tractor, and thus the grain cart, and they can bring it alongside them, and it will automatically stay in sync with the combine. And you can of course nudge it as needed as you fill various parts of that grain cart, but it keeps it right, it comes right alongside you, stays synced with you until you're done, and then you can cue it away, and it will go then to the end of the field to be unloaded in a semi or whatever other thing that you have there. And this has really brought forth a lot of amazing technologies that we've been investing in. Perception is huge. You know, safety is of utmost concern in ag, and especially if you don't have a person in that cab. And so being able to tell what is in front of you and whether or not it's safe to proceed is incredibly important. And it is done dynamically. And so while you have a plan for your combine, the path planning that is done for the grain cart is dynamic. And so you're doing path planning and perception on the fly, real time. And that has really allowed us to push the envelope of what technologies we can bring to market in an incredible way. As we look at the technology that's in there, we know that there are multiple ways and multiple use cases in market that this kind of technology can be used. And certainly this is the first of many that we expect to bring to the market. And so we're focused on this specific use case, but I would say even more, we're focused on the underlying technology that's needed to make this type of thing work. And to my point before about spot technologies, the underlying associated ways in which a customer needs to use this and what all needs to be true of the system and of the total solution to provide that value. OmniPower is the other one, and that is a driverless platform. So that is a U-shaped power platform. As you can tell, it does not have a cab, and you can put on it or in it a seeder, a sprayer, a spreader. Those are the three that we've done so far, and obviously much more could come, and on different shapes of frames, much more that I would say be more ground contact and ground engaging. But this really enables nobody to be on that platform, and it's controlled remotely in the field. In this case, you plan the full path prior to getting started. And this, we are working on this being able to be done by itself, which it obviously can already do today, or being done in conjunction with, so let's say you have a sprayer or spreading operation, being done with a manned machine. And you could see where one would do the waterways and the edges while another does the main area that can go faster, or you could have a large field that you're trying to divide, however the case may be. What has been really awesome about this OmniPower technology is it utilizes the core of all of our technology that we have today, and it has forced us to get to the point of saying what all about our technology has to work when there simply is no cab. There is no engagement with the operator in the field, and what all has to be true about every piece of our technology to get us there. And that has been an incredible journey. The next one I want to touch on just briefly, because I want to make sure that people understand from our perspective, and that's connected workflow. And that's as we push towards more and more either automated or autonomous solutions, the connectivity of what job is needed to be done and what data that machine is picking up as it goes through the field becomes incredibly, incredibly important. Even today, where, you know, for the vast majority, everything's manned, as work gets more complicated, as farms get larger, the coordination of machines and people and activity and the understanding of what happened in that field for your own purposes to make sure you're planning appropriately, for regulatory purposes, all of that becomes more and more critical. And so as part of our solution set, we have what's called connected workflow. And really it's all about making sure that the work and the jobs that you send to the field are the correct ones, that in large fleets, you're understanding where your fleet is, how you can maximize the usage of your fleet, of your people, of your material, and then making sure you're getting all of that back from the field for further decisions, invoicing if that's appropriate, regulatory, all of that different thing. And that to us is a key piece as we look towards the automation and autonomy, because you have to have that connection via data and via information on what is going on there. My encouragement, just to wrap up here, my encouragement is ag continues to be changing. Technology continues to get more complicated. Farming professionals already work tremendously hard, and for us to continue to feed the world, we need to continue to insert technology where it makes sense. And my challenge to people would be to think about, what does the future of automation and or autonomy look in your operation, and what are things that you should be thinking about now and planning for over the next 1, 3, and 5 years? You know, I think the gentleman that shared on the evolution of engines did a great job. It's not all going to come at once, same size, same thing for everybody, right? This is going to come in some markets and use cases faster than others, but I think it will come in some way for everyone. And so being ready for that, given all of the changing dynamics we see in front of us, I think will be really important. Thank you.
Come on. There we go. Hello, Sarah. That was great. That OmniPower thing is fantastic looking. It looks like something that should be on Mars.
Right? It's really exciting. It's fun to watch in motion too.
I imagine it's quite cool, just sort of like trundling around by itself. I mean, I got to kick off. I mean, is there any link between autonomous and artificial intelligence? I mean, because it seems like the two things would go hand in hand.
Yeah, absolutely. I think there are, as you think about, so first of all, autonomy, you don't necessarily always need bigger and faster machines, right? And that's something I didn't get into, but there could be some value in slower and smaller, and time will determine what that ends up being. But that it does allow you to collect a whole bunch more data off of the field. And you think about, a decade or two ago, what a farmer all observed as they were going through the field. That data needs to be collected somehow. And so I absolutely think that both with the data that's collected, but also just the pure perception and path planning, that it's involved in all of that.
Yeah, I see where you're coming from. The other thing too, I know a lot of farmers, a lot of people involved in the industry, they've invested a lot of money in hardware and machinery that they have right now. The autonomous features, can they be retrofitted to older stuff, or are you beholden to buy a new ground up machine just because of the complexity of them, the way they control the systems? I was just wondering if.
That's a great question, and that ties to one of, a gentleman by the name of Roger had the 5 laws of technology adoption, right? And one of them is transferability, and how easy is it for me to transfer and use new technology? Do I have to start over? And so on the Omni Drive, that can be used on existing machinery. And our goal there is not just on the grain cart, but as we build to other applications, is to be able to put that onto existing machines, existing implements, and that's our goal with that one. On the Omni Power, we currently, like I mentioned, support 3 different spreader, a sprayer, and a seeder, and they are used for this, but they are the same frame fit and size that could go on a manned machine or a traditional machine. And so if you don't have those, you would have to buy them. But if you had a sprayer box or a spreader box, for example, on a manned machine, it could be the same and could be used then on this. And that was part of the reason for that.
All right, I got you. Just a couple of quick questions from the audience here. Electrification and autonomy, do they go hand in hand? Are they related at all, or are they kind of look like they are, but they're actually disparate?
So I would say they probably are not reliant on each other, but I see both of them coming to ag in similar ways over the next, decade or so. I don't see necessarily a specific, other than the general sustainability, increased regulatory, increased transparency of farming, but I think some of the same forces will govern both of them. I don't see them as.
And finally, last question.
Yeah.
Is the cooperation between yourselves and an engine manufacturer, is that critical to the success of autonomy?
So I would say today it is not. What I would see, and where I would see this going, is to my point about autonomy may not always mean bigger and better. As was shared earlier, some of that electrification can happen easier on smaller, less powerful machines. And so you could see a scenario unfold over time where a combination of a more eco-friendly tractor or eco-friendly power unit, whatever that is, happen better in a smaller frame and use case. And because you're pairing that with autonomy, it may make sense to have, for example, 2 of those in the field as opposed to 1 much larger unit in the field. And that's where I could see that those working well together. That's
great. That's great. Sarah, thank you so much for joining us. That was good stuff. That machine's still getting me. I love it.
Thank you.
Thank you. Thank you. All right. We'll move on to our next speaker. Swiftly moving on. We have Professor Dr. Till Miner, and he's Vice President and Chairman of Test Center Technology at DLG. And Till will be sharing his presentation entitled Drivetrain Technologies for Ag Machinery in Germany at a Glance. Thanks for joining us, Till, and I'll let you get on. Thank you.
Thanks, Julian, for the invitation. It is a pleasure for me to speak a little bit today about drivetrain technologies for ag machinery in Germany. And due to the short time of 10 minutes, I added at a glance to the head of my talk. Yeah, I speak here to you as a board member of DLG. The DLG is an organizer of the AGRITECHNICA, the world-leading agricultural machinery show in Hanover. And I try to bring in a little bit the farmer's view here into this discussion. So now it works. Yeah, in Germany, diesel is still the energy source #1 for tractors and ag machinery. In this slide, you see that there is no big change happening, or there was no big change happening during the last decade. And there are some good reasons for that. First of one, with a proven diesel engine, almost all drive-related challenges in agriculture could be solved. Thanks to high torques and low speeds, the units also run very economically. And the fuel tanks are big enough for longer working days. Refueling within a few minutes is possible if needed. And that leads me to the next point, which is very important from the farmer's point of view. This is the operating times. As we heard earlier today in the first presentation, there are different usage profiles and special features in ag machinery, especially in tractors. This slide shows you which or how different these usage profiles for ag machineries are in the different power ranges. Starting from the top, we do have the heavy duty soil tillage standard tractors between 250 and 300 kilowatts are normally used for this. And then we do have the mid-range usage, for instance, for crop care, fertilizing, with a range between 90 and let's say 150 kilowatt. Here is shown 111. It goes up to 150. And last but not least, the low power profiles. For example, the yard work or the loading work with farm loaders with engine power less than 50 kilowatts. And this slide clearly shows how good the diesel is performing in comparison to current or to possible alternative fuel systems. And as we heard in the first presentation, especially when it comes to electrical drives, then especially in the heavy duty usage profiles, it is still far away from a practical use in agriculture and on farms. And even most of the other ones, like methane, like gaseous hydrogen, and also the fuel cells, are not able to replace diesel or comparable liquid fuels like vegetable oil fuel, biodiesel, within a short time. More than this, we do have long downtimes due to seasonal applications. For instance, at combine harvesters, in some farms, they work only 3 to 4 weeks a year. or when you look at sugar beet or potato harvesters, you do have the same situation. And this makes the search for suitable alternative drive systems even more difficult. And the last point, if you compare ag machinery with, for instance, heavy truck business, you do often have a great variety of models, and that's why only a few hundred of the individual models are built and sold each year. So this results, of course, in high unit costs for completely new developments. If you look into other industries, then heavy trucks have many similarities with ag machines in terms of engine performance, utilization, and range and operating times. In heavy trucks business, three concepts are in the foreground of the discussion at the moment. This is battery electric drives. These are combustion engines for gaseous fuels, and these are fuel cell drives. And some of those concepts are already realized for ag machines. They are in the market since many years. Here we do see an example for a battery electric driven implement. Farm loaders, for instance, from the company Weidemann are sold since 2015. Followed by other companies, for instance, Schaeffer, and also the e-truck from Silo King. So the second concept are the combustion engines for gaseous fuels. Here, New Holland with this T6 180 methane is starting right now the series production this is an engine for CNG. And we do have other examples, for instance, the dual fuel motor for diesel and CNG from Valtra, and also FPT, as we heard earlier today, will come with such a product. The third concept are combustion engines for hydrogen. Here, JCB with the backhoe loader with hydrogen-powered combustion engines is in the slide, and also Deutz is planning a series production of a 7.8 liter hydrogen motor in 2024. But these motors are not for applications in mobile machines so far. And fuel cell drives are not realistic now for ag machines at the moment. Here are some research projects going on, but yeah, that is not brought to the market within, or this will not be brought to the market within short term. The challenges are always the integration of new drive systems into the vehicle concept, and also from the farmer's point of view, of course, the construction of additional infrastructure for energy supply, like electricity, hydrogen, or methane. Which alternative energy sources for diesel are to be seen for ag machines? Especially with high performance agricultural machines, such as combine harvesters, forage harvesters, or large tractors, a general move away from internal combustion engines in the next 10 to 20 years does not seem realistic, and also makes no sense. If, for example, vegetable oil is used as fuel instead of diesel, the carbon dioxide emissions can be significantly reduced. And this is especially true for decentralized production in small cycles. With all those fuels, it is possible to go on with classic combustion engines, or which are partly modified. Vegetable oil fuel works also with stage 5 engines, including exhaust after treatment systems, a project which was run by John Deere, the Bavarian Technology Center in Straubing, and the Technical University Kaiserslautern has shown this very clearly. Also, multi-fuel concepts are coming to the markets. Multi-fuel, that means vegetable oil, biodiesel, and conventional diesel in one tank. And this technology will enter the market also very soon. And last but not least, special combustion engines driven with gaseous sources like methane or hydrogen can play an important role in ag machines, because farmers do have the possibility to produce those fuels on farm by themselves. I want to sum it up. Combustion engines from methane could be a long-term solution for ag machines, because farmers can produce the methane themselves. This is a different situation compared to truck business, for instance. Vegetable oil could be a part of the solution for ag machinery. There's of course limited availability, but it is interesting for farmers. And electric drives are suitable for light and medium applications, as mentioned before. Thank you very much.
Thank you, Till. That was great. Good information as always. I'll tell you what, I've just got a couple of quick questions. Are you able to stick around?
Okay.
That sounds great. Thank you very much. Hey, what I wanted to ask first off, you know, we're looking at this kind of fracturing of the market right now in terms of different fuel types. Some of them are a bit, you know, they're kind of out there. How is overall in your experience, how open is the agricultural market to new technologies like this? Like, because some of them are a little, you know, they push the boundary a little bit.
Yeah. The ag market is very sensible to prices, to fuel prices. If you look back in 2007, 2008, we had the hype of biodiesel use in Germany, and this has, of course, mainly a financial aspect. So from the technology is there, engines for biodiesel and vegetable oil. It is proven, it works. But the financial aspect is not safe enough for the farmers to invest at the moment. So that is from my experience the biggest point and the biggest obstacle to bring those technologies into the market. And we hope, of course, with the new German political situation, the new government, that they will push the things a little bit forward. Is
there any room in the market left for biofuels that are based on food stock, or is that time come and gone?
This time is come and gone because the acceptance in the society is not there anymore to produce fuels from sources which can also be used as food.
And how about this? Okay, so it's the end of biofuels from food stock. You wouldn't be forecasting the end of diesel at any given point, would you?
Please say it again. I didn't get the question.
Oh, you wouldn't. Do you think that diesel still got a role to play?
Yes, for some applications, as I mentioned, of course, I'm convinced that diesel will continue to play a role at least for the next years. Yeah.
Gotcha. Okay. There we go. There we go. We heard it here. All right, Till, thank you very much. Thanks for your presentation. Thanks for joining us.
Thank you.
Appreciate it. Thank you. Okay, our fourth speaker today is Rakesh Koneru, and he's COO at Hummingbird EV. Now, Rakesh has been with the California-based Hummingbird EV for 6 years, first as Director of Operations and Business Development, before taking over as the company's Chief Operating Officer. So Rakesh, please start your camera and your presentation. Thank you very much.
Hello, everyone. Thanks for putting us together, Julian. All right, so again, we're Hummingbird EV. We're based out of California, and we've been around in the space for about 6 years now, a little over 6 years. Our expertise has always been in the medium and heavy duty on-road and off-road vehicle industry, where what we focus on is mostly on the electrification side of the heavy duty market segment that includes the agriculture, mining, off-road and on-road vehicle applications. So what we try to, our vision internally is to provide solutions which is more catered towards an end-to-end solution provider rather than just being a vehicle guy or a charging station guy or a specific technology. Because what we'll see as we evolve with the new technologies is currently the customer is responsible for taking the ownership of getting and trying these new vehicles out, including charging stations, so on and so forth. But they're not well educated enough to make a decision of what vehicle is going to fit for their application and how they can accommodate the vehicles into their operational needs, right? So we come in with that mindset of how do we, tailor make a powertrain system to an application, and how do we minimize the effort from a user side to speed up the whole process of electrification. So that's what we focus on. Again, with that said, everything that we do in-house is unique to us, and we focus on the electrification side of business. We're not a chassis level up guys as of right now, but so for example, when we go to an agriculture farm, we get to know the application and the use case, and we start from a system map level, defining all the way from the cell level up. So we do have our own battery packaging that we do, including our own BMS in-house. And where we're unique in is also we have a unique drive system, which is smart and which enables for multi-platform use. What it means is, we have a software-driven system. Whether the vehicle is an ag tractor or it's a Class 8 truck, we sort of use the same powertrain system with just the software configuration for multi-use, which can reduce the cost over a period of time for the end user. So our technology is also a little bit unique in the sense of we have a unique powertrain system which will enable the driver, a user, to drive and charge using the same power electronics. So what it enables is it helps us to, at no added cost to the consumer, we can do fast onboard AC charging rather than needing an expensive DC fast charger. That's all done with our unique powertrain system, which is inbuilt into the vehicle platform itself. And with that, we had to go and develop our own type 2, AC level charging station, which is capable of handling about 150 kilowatt of charging. Now, specific to this conversation, to the ag space, our approach has been a little bit different. Being in the startup environment, we've started to look at the industries, the evolution of EVs in different, different industries across the globe. And one of the industry that was not much focused on and, in trying to reduce the emissions so far, we feel is on the ag side of it. And now when you see agriculture plays a key role, which is about 30% of land in the world is used for agriculture. And most of the emissions is as the professor earlier has mentioned as well, there's quite a bit of emissions that contribute from farming side of it, and there's not many solutions out there. You'll either see an OEM coming up with an ag tractor, or you'll have companies who's more focused on the infrastructure, but the handshaking between these two technologies is left to the user, and that can be very challenging, and especially when you get to a farmer who doesn't care what vehicle he uses or what vehicle he drives. It's all about cost, right, and the reliability of it. So we've understood the drawbacks of, I wouldn't say the drawbacks, it's more the complexity of the farming. And what we tried to do as a proof of concept was we worked with the state of California, we worked with a grower here locally, with the idea of showcasing a net zero fruit to bowl concept. And the main drive for us was to understand all the way from fruit to bowl, like, getting the fruit off the tree to getting it into the warehouse to packaging, and from packaging to distribution centers. We wanted to replicate a net zero concept. So with that, what we've done is we've engaged with a farm group who has a 2 megawatt solar out in California. And we wanted to, as the first run, as you guys see in the pictures, we worked with an OEM from on a tract, from a tractor chassis perspective. And again, we went with a blank sheet of paper. We tried to understand the whole operations of the farm, the number of tractors they use, the type of tractors they use, the use case, hours of operation on an average a year. And what we noticed was, I think it's also geographical, but where we are is farm tractors are only being used probably 50% of the time, whereas the rest of the 50% of the time are being left out, not being used because of the winter season, so on and so forth. So what we have done is we've taken 4 electric tractors, 50 horsepower equivalent, and we've electrified them from a chassis level up. And what we have also done is, because these farms are huge, you can't expect these tractors to get back to the barn every day at the end of the day, daily use. So we had to think a little bit of, we had to be a little creative. And what we did was we tried to understand the energy source today, which was a diesel trailer getting pulled into the field to fill in the fuel for these tractors. So in that sense, what we did was we replaced the tractors with electric, and we replaced 2 of their diesel trucks with 1 electric truck, which can go around its daily routine. And at the same time, at the end of the shift, it can get back to the tractors and charge 2 tractors simultaneously from its own battery pack. Now, what the whole idea was, how do we use a vehicle-to-vehicle charging, and how do we accommodate where the tractors don't have to get back to the barn for charging these things. Now, these vehicles have been in the field for over 2 years, and again, all the way from the battery pack size, whether it's for the truck or the tractors, we have defined it to the use case and the user application to withstand 2 days of operation on a tractor and a days of operation on a truck. So all the pack size, the powertrain, everything is sized to the application. Because again, like I keep saying, farming is quite complex. The type of crop, the geographical conditions, a lot come in play, where one solution is not going to be fit for all applications. So we've tried to replicate that farm, and there were, a lot of lessons that we have learned, feedback from the farmers, so on and so forth, which I'll explain a little bit down the line too. But again, so what we wanted to do with the first project was, how do I get the fruit from the tree into sort of, warehouse and the packaging locations. Then we further expanded the project where, again, this is in conjunction with CARB as well. Now, what we tried to do here is try to take that fruit from the packaging site into the distribution centers. So with that, we've worked with an OEM from a chassis level up design again, to design a truck which is electric, but not just the truck is electric. Even the refrigeration box is driven by the high voltage battery pack that drives the truck. So in this sense, it's all net zero. Again, when you look at it from a solutions perspective outside in the market, either there are players who deal with trucks on the electrification side of it, or just the reefer from the electrification side of it. But it's time, money, and cost, right? So unless you do a vertical integration where you minimize the stress to the user, and it's like a one-stop shop where they feel comfortable working with a company who can cater it to an application, we felt it's going to be really hard to push ag into agriculture, where the mindset today is I have a tractor that's 60, 70 years old, and I would rather fix that and let it drive rather than try something new that's expensive, right? So we're a little bit unique in the approach of what where we want to be and what we want to do. Now with the lessons learned, I think where we're focused on more in future is we feel there's a chassis level of design that has to be redone and rethought when it comes to the ag equipment, particularly the tractors themselves, because honestly, when you look at the tractor chassis level design, it hasn't changed probably for about 70, 80 years. Right. And from a regulatory perspective, there's been a lot of push to, to take the older units out, but there's not new stuff into the market, and the users are not really comfortable, trying new technologies out. So what they keep doing is, they're replacing a tractor with an ATV or an UTV to do a tractor job. And in our sense, if you can define a tractor from a chassis level up, it can perform multitask. It can be an ATV, it can be a UTV, it can be a tractor, right? All three units can be a single unit. I think that's kind of the design idea that we're pushing towards too. And at the same time, electrification brings in unique opportunities where you can do vehicle-to-vehicle charging, for example, like I've said earlier. And the big part of it is the V2L, the vehicle-to-load, right? So now, again, it goes back to my earlier conversation. Tractors are being only used half of the time. In winter time, their needs, they can fit in a different requirement. For example, winters can get cold. The farmers, they engage, they do a lot of other, to heat the farm up. They light up the farm. They use, heating blankets. They do all sorts of things. So if you do have a mobile electric vehicle source, you have flexibility to go light up the farm, or to go run your water pump, or to go run your tools. So you can maximize the use case, and you can minimize the number of equipment you can buy down the line. And that's one big option, opportunity out there. And that's what we're focused on right now. And obviously the autonomy part comes in as well, to this mix at a later point. But one major thing that we have seen was the grid stabilization when it comes to the farms is not the same as you see in the cities. So the grid fluctuates quite a bit. So what it means is the energy losses are huge to the farmers. And now when you start pushing electrification, their electricity bills are going to go up because of the unstable grid. And so with that in mind, and the farms being so huge, we wanted to explore the concept of also how do we bring in this whole technology with a microgrid, infrastructure in mind. So that's something that we're also working on. Now, one other thing, is, climate change is also playing a key role in trying to push farmers to try new things out. Let's say, for example, in California, we had pretty good, last decade has been hard on us, and drought seasons have hit pretty hard. So what it did was, state came out and they had a regulation at some point where the farmer has to cut the farmland by 25%. So now the farmer has to, get to the same yield to run his operations. So now the whole farming is getting to a point of, how do I get to the same yield in the same, with that 75% of the land? So with that, the chassis are really are going to be really a game changer, we believe, in over the next decade, because the trees are getting closer, they're getting smaller, they're getting more closer to the earth. And navigating through these fields, and especially every farm is different, every cultivation is different. And that's where we feel a chassis level up design can be really beneficial. And it's, and we believe that's where the industry is going to focus on next, apart from the electrification standpoint. Now, we have had
Rakesh.
Yes.
Rakesh, I'm very sorry. We've just got a minute or two left. Can
Yeah, no, I think I'm done, Julian. If you guys have anything else, if you guys are interested in learning more about us, I've had a couple YouTube articles, to sort of understand the application better. With that, that's all I have.
That's great, my man. Thank you very much. Thank you very much for the presentation. Have you got time for just one quick question?
Yeah, please.
Can you close your presentation down?
1 second. How do I do that?
There you go. And we're on. I just wanted to ask one quick question, and I think it has to be asked. You are desperate for new battery technologies to come through, aren't you? I mean, that's really what's going to make or break you guys.
Yes, true.
I mean, if you get solid state batteries, I think that you're going to have a line of people at your door, I would imagine.
Yeah, no, always the question that was in our mind, Julian, was always, do we give flexibility for battery swapping, or do we provide a technology that can go in and just charge, right? So it's a chicken and egg. Getting a battery swap is good and fast, but at the same time, it needs proper jigs to handle it in the middle of nowhere. And at the same time, you're adding it to the cost of the equipment, right?
Yeah.
So farming is a little bit challenging, and the same 50 horsepower tractor, one user may have a 2-hour, it's depending on the crop, right? I may have a 25 kilowatt hour that's going to be good for this guy, and a 50 kilowatt hour that's going to be good for the other guy. So it's scaling it as you go to the application is quite a bit challenge. But
everything's turnkey.
Exactly. Yeah.
Yeah. Cool. All right then. Thanks very much for the presentation. Appreciate your time. Thank you. Okay, our penultimate speaker today is Charlie Anderson, and he's CEO of Burro. Now, Charlie has a background in farming. His family was involved for a long time, and it's an experience that led him to believe that the work should be automated. So here we go. After a spell with FPT Industrial in North America, he founded Burro to investigate development of these technologies. So Charlie, thanks for your presentation, and let's see what you got.
Awesome. Thank you so much. And let me just share my screen quickly. All right, can everyone see my screen?
I can, definitely. Thank you.
Perfect. All right, so my name is Charlie Anderson, and here with a company called Burro. Thank you very much for having us here today. I think when the problem that we're tackling as a company is the labor problem within agriculture. And this has some particularly relevant attributes to people kind of that are part of this event. So the reality is that nobody wants to get up and drive into the field in 110-degree heat and work an 8-hour day. It's not work that people want to do anymore. And I think when people think of ag, they tend to think of somebody sitting on a tractor in the Midwest somewhere, and that is where CNH and Deere and Kubota and a lot of these other mechanized companies make their margins, because a lot of stuff there is mechanized. And the reality is that something like 88% of the US crop workforce works in fruit, vegetable, and nursery crops, where hand labor is oftentimes north of a quarter of revenue. So every dollar in revenue you generate, something like 20 to 30% goes to labor. And there's not really any mechanization. And it's really a space that needs automation. And at the same time, while robots are very clearly the answer, most of the stuff that is being built to offset hand labor is stuff that requires that farms be comprehensively rebuilt, or it requires that farms be completely rebuilt in order to function, and also require that the company sells the product with an operator. And to us, the world needs something that works out of the box today, can go into existing operations and be operated by existing people that work in those operations. And that's exactly what we have with our launch product. So these are Burros, the product you see on the screen. And what these are little computer vision-based autonomous platforms that carry heavy things in hand harvesting operations in areas where you've got people running around in the field doing various tasks. And what's really, really key to this approach is our use of computer vision as the dominant sensor modality. Computer vision has a couple of very important attributes. One, it's actually pretty low cost. So we're basically using cell phone cameras to navigate. Two, we're able to navigate under canopies. So we're able to go into areas where you don't have GPS or can't see the sky reliably. And now those areas tend to be the areas where people work. And then the third attribute of vision is that the more you run, the more you learn. And so each one of these platforms processes about 2 terabytes of imagery per hour of runtime. That imagery can be used to do things like tell you how many clusters of grapes there are on a vine, ultimately to do things like autonomous picking. And the more we run, the more we have what is effectively a sponge-like or learning platform that is learning about the environments where people work, and to which we can add more and more capability over time. And then beyond that, on the mobility side, as we are putting these things out into the world, we keep having customers come up with other kind of funky use cases that we never would have dreamed of as they're kind of thinking about new ways of using the product. And so people are putting them into a whole host of different applications, both daytime and nighttime, that are increasingly interesting for a variety of different reasons. And so to us, I think people are very, very good at predicting where the world is going over the next 15 to 20 years. And I think in the next 15 to 20 years, we know that you're going to have robots running around doing a whole host of different tasks within agriculture. But what people really struggle to do is to predict how to win in years 1 through 5. And to us, if you imagine small robots akin to Disney's WALL-E or R2-D2 running around, perceiving the world, or perceiving stuff within the world and then manipulating things, the way that actually begins is likely with a collaborative vision-based platform that works alongside people and that learns to do more and more things over time, ultimately ending in that kind of 15 or 20 year from now end goal, which again is small robots running around doing the stuff that people do today. And so with that, the autonomy we have today is encapsulated on this slide. We have an approach that we've developed that we call pop-up autonomy, which we have patented, or at least is patent pending globally. And with that approach, the robots each behave as an individual actor and can be operated out of the box without any infrastructure needing to be installed. And so if you're a user, you grab one of these things, unload it from a trailer or from some point, have it follow you to where you're going to use it, and then you can train it over relatively short routes. Those routes can be extended if they're structured in environments like roads or rows, and the robots are therefore able to learn very quickly how to run autonomous routes in a variety of environments. And separately, every single unit is online and all units share data between other units. And what that means is that if you have one robot in an environment with a bunch of other ones, you can train one unit to a vineyard or to a route and quickly have all of the other robots on site know that route. And so you've got this kind of natural swarming impact that can create a lot of really, really exciting possible use cases. With that said, the initial use case that we're primarily doing today is within table grape and blueberry and other berry production, where the robots are trained over a relatively short route, and then they are running that short route, including a row, all day long with a bunch of people using an asset. And with this type of utility, or with this type of mobility autonomy, you can deliver something like a 2 to 3 month ROI with a product out of the box that's also the basis for more autonomy over time. And so with this as kind of foundational stuff for the product, to us, what's really exciting about this is that it's a people scale platform. So we're competing with a person doing work. We're not really competing with a big tractor because those don't really exist as tools within our existing use cases. And if you're a people scale platform that can work alongside people, you can go into table grape production and blueberries and blackberries and raspberries and nursery crops and persimmons and other stone fruit and solar panel operations. There are a whole host of use cases where you've got people running around doing a variety of tasks. And then beyond that, we keep encountering additional use cases. And so here you're seeing a crop scouting type of utility we're developed, where you in a traditional world, you'd have a guy, he drives into a block, he looks at a couple of vines, and on the basis of scouting 2 or 3 vines, makes a decision on 1,600 acres. In our case, with our robots, you can send them up and down rows autonomously, counting the clusters of grapes on every single vine. And I think there are a whole host of tasks where people walk up and down through environments, look at stuff around them, and then count or scout, that something like this product can do. And beyond that, we're also seeing them getting used in nursery operations where they're used to tow trailers. And the appeal of this use case is that you can take a machine and set it up quite quickly without having to install tape or an induction line or anything else like that on the ground, which is what a lot of existing stuff would otherwise have to do. And so relatively rapidly, you can have an infrastructure-free autonomous towing platform in a whole host of different nursery type settings. And additionally, we're again seeing them go into use in a lot of other berry type operations, et cetera. So I think there are a whole host of different use cases where you have people running around in indoor, outdoor settings under a canopy or out in the open that can utilize a product like this at some level. And what is key to our platform working ultimately is this approach to autonomy that learns continuously and can navigate and localize under a canopy in areas where you couldn't operate with GPS. And all of that is packaged into something that anybody can operate. So these things are operated by something where we typically have about 500 to 600 people operating them a day right now. So they're very widely operated, and they have also been pressure tested over about one drive around the world. So we've done about 25,000 autonomous miles at this point. And our autonomy, as it's gone through those 60,000 hours of operation, has reached about 15 autonomous miles per intervention. And that number continues to rise. So we are selling something that drives itself in an increasingly reliable format. And on the hardware side, we've now been through about 8 generations of hardware. So we have about 95 or so units running daily right now in paid commercial use. And we're going to be unveiling our 8th generation machine at the World Ag Expo, which is coming up here coming up here early in the spring. And so our generation machines are actually in production now and can be ordered today for April or May delivery, assuming the global supply chain maintains at least its current progression, doesn't get worse. And so with this as kind of scoping, I think when you think about the future, and when you think about where autonomy is going, to us, there's this opportunity to build people scale robots, not machine scale, that are doing things that people do. And those use cases for those types of things are not immediately obvious to everybody. And so we have chosen initially a couple of specific use cases around mobility, or adding in data and dexterity, and also branching out into a couple of different adjacencies. And I think if we look at the world 10 or 20 years from now, you're going to have small robots like these running around doing a whole host of different tasks. And I think that's really, to me, very, very exciting for a whole host of different reasons. So with that, we are Burro. I think we are building a people scale collaborative robot that is really the basis for a lot more autonomy in a lot of these different areas. If any of this sounds interesting, you can visit us online at www.burro.ai or email me at charlie@burro.ai, and we will be at the World Ag Expo in Tulare, California, February 8th through the 10th, if anybody wants to see some of these in person. So with that, I think that's what I have. I'm kind of coming up on 10 minutes, so happy to take any questions. And again, really appreciate the time.
That's great, Charlie. Thank you very much. That was a super presentation. Really enjoyed that. Hey, I'll tell you what, you know what really occurs to me? You've got each of these robots with their vision, and they're transferring 2 terabytes of data each. One, where's the data going, and how's it getting there when the machine's stuck in the middle of the field?
Totally. So I think data, you don't want a lot of data, you want the right data. And so we process 2 terabytes of imagery per hour of runtime, but we only push a tiny, tiny fraction of that out of the machine.
All right.
And the reason the stuff we push out is, I guess, for one, kind of status of equipment, but separately, if it sees something it hasn't seen before, just the thing it hasn't seen is pushed out, not everything. And so as you have more and more machines running, each machine is actually pushing out less and less data per machine, but the data it's pushing out is increasingly relevant because it's new stuff that the whole system hasn't seen. As you have more and more machines running, it therefore becomes a lot more reliable because you're basically capturing these weird edge cases, that you want to be able to address.
As soon as something unique comes up, that's when all of a sudden the system goes, hey, that's unique. I need to transfer that.
Yeah, and it would be weird, stray dogs, drop Bluetooth speakers. We have a module where you behave differently depending on the truck you see. So if you see a car, a truck, or a truck, the behavior for a truck is a lot different than a car or like a person-sized truck or a normal truck. And so every time we're encountering odd scenarios or new devices, we are learning or saying, hey, we haven't seen this before, pushing that centrally. And so what you have is a sponge that is going forth into the world and sucking out just the relevant stuff about it to the point that you can therefore drive more reliably within it.
Just really quickly, any chance, I mean, everything that we're talking about here is on a vine, on a small tree. Any chance of moving into automated root vegetable picking? Is there any potential for that?
I think when I look at companies like Oxbow and some of these other ones that make very good mechanized harvesting systems, I think we try to pick our battles properly. I think the battle we want to pick is one where you've got people doing work they don't want to do that can't be mechanized by a large existing system. And so if you're in something like leafy greens and you need a vehicle to carry things autonomously back and forth around people working, that could be something we might do. But if you're talking about, harvesting something like broccoli, that's probably more of like a Ramsey Highlander or Oxbow type thing, as opposed to something that we might do.
All right, sounds good. Hey, Charlie, good luck with your enterprise, and I hope you have a good show in the spring.
Yeah,
maybe we'll see. Maybe some of us will see you there.
Yeah, totally. I would love to see people there for sure.
Great, nice one. Thanks, Charlie.
Yeah,
okay.
Thank you.
Last, but by no means least, of our quick fire presentations today, we have Peter Blade, and he's head of autonomous vehicles at Danfoss Power Solutions. Now, having been an engineering officer in the US Navy, Peter joined Danfoss Power Solutions 2 years ago. He has now taken over the company's new +1 autonomy business. So thank you, Peter. Thank you for taking the time to join us. And let's see your presentation, sir.
Thank you, Julian.
Thank you.
I'll just share my screen here and let me know when you can see it.
There we go. You're up and ready.
Great. So as Julian said, my name is Peter Blade. I'm from Danfoss Power Solutions, and I run our autonomous vehicles group. I'm based out of Cambridge, Mass, and leading a team that's really worldwide, focusing on both software and hardware and really every layer of autonomy, and talk about kind of what we do and the problems we see. The first is really a lot of the talking points that we heard from today, or especially around the autonomy, is there's a problem in a lot of different industries, not just agriculture, but agriculture is seeing, I think, the brunt of it, around of a lack of experienced labor and then a general labor shortage. You know, some statistics really focusing in again on the fruit, vegetable, specialty agriculture markets had over $3 billion of crops not harvested in 2019 in US and Canada solely due to labor purposes. And so we're seeing a lot of issues that really kind of boil down to and are causing a need for vehicles to have some extra capability around them that kind of gets summed up into autonomy. And what those extra capabilities really are is more safety. And that kind of goes to the lack of experienced labor, and that a newer person operating a vehicle or somebody who's seasonal and doesn't operate vehicles very often may not understand the complexity and the more and more complex vehicles that we have, and that added level of safety that the vehicle intrinsically has is a priority. A higher level of productivity, needing to do more with less overall, because there's less labor or less availability of labor to harvest and to do a lot of things, and the vehicles themselves need to become more productive. And lastly is precision, being able to perform precise tasks and kind of to build on those precise tasks that really drive to solve a lot of these issues. So at Danfoss, when we look at our +1 autonomy solution, we focused around these three areas. And if we can deliver these, functions, then we can really start to solve what the core issue is and what's driving a lot of autonomous vehicles in the industry. When we talk about Danfoss in general, and when we look at the industries that we see, we really talk about autonomous vehicles, and we always say autonomous vehicles, but really the discussion is more around autonomous tasks. Every vehicle has a number of tasks that it does. Some of them do 1 or 2 or 3 tasks, and some of them are very utility vehicles and can do up to 1,000 tasks, like a tractor can, depending on which implement it might be pulling behind it or what it might be doing that day. And because of that, we're seeing certain industries, the labor-heavy industries that have that lack of labor, or the vehicles that don't have many tasks, automate quicker than others. And so what you might see is lawn and turf and road building, specialty agriculture, ground support may be automating quicker than, or appear to be automating quicker than, what you see in construction and row crop and other things like that. And that real push is where we're seeing, again, a lot of the need is around these automation of tasks around vehicles, again, focusing back on safety, productivity, and precision. With that, the question is really around, what does Danfoss do, and what do we provide? And so for those that are familiar with Danfoss, a lot of people know us as a hydraulic supplier, or sometimes the thermostat that's on in your house in mostly European countries. When we talk about autonomous vehicles, we really do 3 different things that kind of are needed across all vehicles to start to solve some of these problems and start to add some of these functions in. The first one is the hardware. As you start to talk about more and more complex operations on a vehicle, you need higher processing power. You need sensors and perception around you. And while we don't build those sensors ourselves, we really focus on the partnerships around those sensors and the ease of integration for those sensors to help to drive these functions. But also we need the basic hardware, like a steering system, to be electrified, to be able to start to take in more and more of the software commands, as opposed to pilot hydraulic or other commands. When we move to the software, where Danfoss focuses is really around building software tools, and software tools through our +1 platform that any OEM or any user can pick up and quickly build the basics of an autonomous vehicle. And there are some functions like path following, perception, and obstacle detection, obstacle avoidance that are absolutely going to be required for almost every vehicle across every industry. And by building up those basic functions that are going to be critical, What we allow is the OEM to then focus on that last 20% of the vehicle. And that last 20% is unique. It's the unique function that that vehicle does, that that OEM provides to its customers. And so by building up our software tools and offering kind of free software tools right now inside of our +1, with any +1 license, we offer the free autonomous control library today that really lets you take those tools and start to build up a vehicle with some of the basic functionality so that you can get there quickly and then focus on that last 20% really yourself. And then lastly, we offer engineering and software services, and that's that last 20%. You know, some customers would instead of doing it themselves would come with us, and we can also help, and because we see a lot of use cases, can really leverage our software and our engineering and our experience to help to do that last 20% with you, to get the vehicle to the right level of autonomy that you want it to be and get the right level of safety, productivity, and precision into your vehicle. And why is all of this important? Why is it important that there's kind of solutions across the full area for OEMs and for vehicle manufacturers? It's because really, when you look at an autonomous vehicle, it's not just one piece or part. And like we said, we're really talking about the tasks the vehicle does that you're looking to automate. And so when we talk about the different layers of vehicle intelligence on a vehicle, the execution layer and the control layer, that's almost what every mechanized machine has today in terms of, propel systems and work function and steering systems. And that's really managed a lot by hydraulics and electric motors and a lot of the other technologies you heard about today. And that really is controlled right now a lot by the electronic controls, and that can include HMI joysticks, remote controls, but also just your regular microcontrollers that are driving a lot of it. As we start to automate more and more, and we start to push the safety, productivity, and precision onto the vehicle itself as opposed to onto the operator, what you start to need is higher level algorithms on the software side, and you need higher level processing to drive that. In addition, you need to understand the world around you, and you need higher level processing to take that in. The last speaker just talked about 2 terabytes of data. That's something that's never going to fit on a microcontroller. So if you start to talk about the agriculture market and needing hardware that is ruggedized and also has the equivalent processing power to start running a lot of the vision algorithms and things like that, it's critical that those things exist, and they exist in the context of ruggedized vehicles and in outdoor environments. So when we look at the decision layer, providing the hardware and the software libraries that get you there quickly to help to build up the basic functions around your decision layer so that you can, again, focus on that last little piece. The other things, and these are things that Danfoss doesn't provide, is the last 2. The perception layer is how the vehicle understands what's around it. And while we consume a lot of that data in the decision layer and make decisions, around obstacle detection, avoidance, and perception in that decision layer, the sensors themselves are high technology in and of themselves. And one thing we've realized is that the problem is normally integrations. It's really hard to take a sensor off the shelf and integrate it into your system. People can spend 3, 4, 5 months of writing code to get that full integration done. And so what we focused on is really partnering with the best in the world that provide those sensors and provide that easy integration into our platform to just allow simple overall sensor integration that's really as close to drag and drop as we can get it for the customer. And lastly, and I think one of the earlier speakers talked about, how do you tell the vehicle what to do, right? Especially as you move from operator assist functions and the level 3 autonomy with the operator still on the vehicle, and you really move toward that driverless or maybe a supervisor in the field, but the vehicle is still operating by itself functionality. How do you tell the vehicle what its tasks are and its understanding? And really, at the planning layer, Danfoss is not an agriculture or construction or any of those like core asset companies, and so we are relatively agnostic to working with whatever platform needs to be there to really push that information down to the vehicle level to give it its tasks, and then let the vehicle run those tasks on the edge. So when we look at the integration layers, as we talked about, hardware and software matter, and they matter at every single layer and how you manage and how you operate an autonomous vehicle, but at the same time, the integration between all these layers. And no one company is going to own the entire vertical stack, the perception sensors, the controls, and more, the execution layer, decision layer. Those are going to be really kind of focusing in on experts. So the ease of integration between those things and the understanding there kind of critical to Danfoss's journey and what we can provide OEMs in the agriculture market to, again, increase their safety, productivity, and precision of their vehicles. With that, that is all I have, Julian.
Peter, thank you so much. Thank you. Hey, I'll tell you what, just to kick off, I have a Danfoss thermostat in my house, so I know I knew the name long time ago. Hey, just a couple of quick questions, if I may. I think it'll be interesting to a lot of people watching. Once you determine that you, in your particular, I mean, I know it's kind of like asking how long is a piece of string, but at the same time, if you've got, say, a harvesting job that you need done, once you've decided to implement an autonomous system from Danfoss Power Solutions, how long does it take before you're actually up and running?
Yeah, so it depends on the use case and obviously what kind of level of autonomy you're pushing toward, you know, no human intervention versus operator assistance. But really, like I said, those basic tools we think save about 50% of the development time. And that includes a lot of the integration in with the sensors and other third-party things to bring that all together quickly is a priority. And then really that saves that other time to be tuning your vehicle, you know, tuning the steering around the exact use case and what the vehicle actually needs to do and tuning those functions. So again, depends a lot on the actual use case, but what we're shooting for is almost 50 to 60% reduction as we build up our platform would be our overall goal.
Gotcha. Now all the different blocks that come together as almost like a plug and play Lego system to develop the actual solution. I've seen before, particularly in robotics, where they have open source setups where customers who solve a problem can put their solution up available for other people to use. Is that something that, whether maybe you don't have it now, but something that might be considered?
So, like I said, with the normal +1 license, all of the library today is free to users at that point. And the important part there is while you can take ROS or some other libraries that might be open source and free, ours is built completely in the context of that +1 operating system. And what that allows you to do is take that autonomous block, that autonomous Lego block, like you talked about, you know, maybe and integrate it with that third-party sensor and then work directly with your e-steering system or a remote control system and be able to bring all of those together in one control system, one setup very easily. And so while the others might have libraries or build-arounds specifically in the context of autonomy, we really focus it on being able to integrate to all the components of the vehicle across all of those layers.
Oh, I see. I got you. Now, my final question would be the hardware and machinery that has to be bought specifically to run with the Danfoss solution, or again, can you retrofit the hardware to run with an existing tractor?
So from the controller hardware, especially around the decision layer and the higher computing power, that is something that we focus on with the Danfoss solution. But in terms of the microcontrollers or the hydraulics, we have worked with other providers at those levels at those different layers. And the important thing is that, like I said, the ease of integration between the layers. And so it's all about just defining what those inputs and outputs are. And once you understand those, you can put it onto a system that might not be using a Danfoss control layer, might not be using a Danfoss execution layer. Obviously, from the Danfoss perspective, we do work kind of optimized with our own things, but that doesn't mean we don't work with other equipment either. So
Sure. Okay, Peter, thank you very much for your time. Thanks for the presentation.
Absolutely, thank you.
That was great. Thank you very much. Okay, ladies and gentlemen, I think that brings to a conclusion today's webinar. Once again, I'd like to thank all our presenters from FPT Industrial, Raven Industries, DLG, Hummingbird EV, Burro, and Danfoss Power Solutions. I'd also like to thank our sponsors, our gold sponsor ZF and our silver sponsor Cummins. And if you've missed any part of this presentation, or if you'd just like to check it out again, if you'd like to hear my dulcet tones one more time, you can check out the AGRITECHNICA website, because this webinar will be there to stream and download at your pleasure. And finally, ladies and gentlemen, I would like to thank you all for joining us It's been a pleasure. My name's Julian Buckley, and I'd like to thank you. And please join us again for our next show. Thank you. Bye now. Bye-bye.